Hi, today I'm going to be showing you how to find the actual rational zeros of a polynomial equation. So, I'll be showing you the equation based on my last name, which is f of x equals x cubed plus 14x squared plus 25x plus 12. So what we're going to do first is we're going to be using rational zero theorem. So you're going to find the trailing coefficient, which in this case is 12. And then you're going to find all the factors of the trailing coefficient, which these are all of them. You put like the positive and the negative because you're going to be checking both the positive and the negative of each factor. Then you're going to find the leading coefficient, which is 1 in this equation. And then you're going to find like the possible values of p over q. So you're going to like factor it to find p over q, which are all of these. And again, you put both the positive and the minus because, yeah. And then once you simplify those and, like, remove any duplicates, then you kind of just end up getting the same factors for the trailing coefficient. Then next, you're going to be checking all possible roots. So you're going to be checking both the positive and the negative of all of these values using synthetic division. So I just showed an example on here, and I did the other ones on a different piece of paper for the sake of showing you. But the first example is just the value of positive 1. But all you're going to do is you're going to take the equation, which is, again, x to the cube plus 14x squared plus 25x plus 12, and you're going to divide that by x minus whatever value you're checking. So if you're checking positive 1, then you're going to divide this equation by x minus 1. And then if you were checking negative 1, then it would be this equation divided by x plus 1, if that makes sense. So I showed synthetic division here for 1, and 1 is not an actual zero, but if you go through and you check all of these values, both the positive and negative of each number, then you will find that negative 1 and negative 12 are the actual zeros, and you will know this if the quotient of the check equation is equal to 0. So if it's not equal to 0, then that means it's not an actual zero. So the actual zeros of this equation are negative 1 and negative 12.